ABCD is a kite. AB equals AD and CB equals CD. The point B has coordinates K1, where K is a negative constant. The point D has coordinates 8, 7. The straight line L passes through the points B and D and has a gradient of 3 out of 5. Find the equation of AC, giving your answer in the form 𝑝𝑥 plus 𝑞𝑦 equals R, where P, Q, R are integers. So that's the kite, and A, B, C, D, I've named it as per the question, and we have AB equals AD and CB equals CD, and the coordinates BK1 and D87, and the line L, that is the diagonal, and the BAC is also the diagonal, and the diagonals are at right angles to each other. We use the properties of kite, so AC is perpendicular to BD, and also AC bisects BD. So I named the midpoint of BD as E, and we've got to find the coordinates of this midpoint. We'll do that, but before that we got to find what K is. So using the formula of gradient, we can say, so we know that the gradient is also, so we know that the gradient we can write as y2 minus y1 divided by x2 minus x1. So that's what I have done. So if this was, if point D was x2, y2, and point B was x1, y1, then y2 minus y1 would be 7 minus 1 divided by 8 minus k, and that would equal 3 out of 5. So if you go on, so therefore it would be 6 out of 8 minus k equals 3 out of 5, and 6 times 5 is 30, that equals 3 times 8 minus k, and then we get k equals minus 2. So the point B would be minus 2, 1. So now we need to find the coordinates of E, and the coordinates of E, because it's a midpoint, we use the midpoint formula. So that would be minus 2 plus 8 divided by 2, because the coordinates of B are minus 2, 1. So minus 2 plus 8 divided by 2, and 1 plus 7 divided by 2. So we get 3, 4 as the coordinates of E. So the next step is to find the gradient of AC, because we need to find the equation of the line, equation of AC, and obviously it's of the form y equals mx plus c. So the gradient of AC is minus 5 out of 3, and that is because the product of gradients of AC and BD should be minus 1, as they are perpendicular, and therefore 3 out of 5 times minus 5 out of 3 is minus 1. So therefore the gradient of AC is minus 5 out of 3. And so the equation of AC is going to be y equals minus 5 out of 3x plus c. That's the gradient, 5 out of minus 5 out of 3. And so we got to find the y-intercept c, and we know that AC passes through E, 3, 4. So we can write, putting in the values of x and y as 3 and 4. So 4 would equal minus 5 out of 3 times 3 and plus c, and that would give us c equals 9, and that means the equation of AC would be y equals minus 5 out of 3x plus 9, and because we have got to give it in the form px plus qy equals r, so we cannot leave it there. So if you multiply it throughout by 3, you'd get 3y equals minus 5x plus 27, and then bringing minus 5x to the left hand side, it would be 5x plus 3y equals 27, which is of the format px plus qy equals r. So our answer is the equation of AC, which is 5x plus 3y equals 27.